AWS Redshift architect, what is leader node, what is compute node, what is node slices, how client application connects to AWS Redshift, what is cluster and all. So now let's discuss more on the distribution, like how we distribute data in AWS Redshift. So this session is about the table distribution. So this is like very important thing. Like when we select AWS Redshift as a data warehousing solution or data warehousing technology, then this is very important to distribute your data. If your data distribution is very good, you will get really better performance. And if it is not, then again like you will end up even like paying a lot for the infrastructure and for Redshift, you will not get as expected performance. So this topic, data distribution or the distribution style, is very important. So when you create a table, you define the distribution. So now in like 2019, the first quarter, they announced the one more. Earlier there was like till earlier there was only three distribution style. So like the all distribution, even distribution, and the key distribution. So by default it was even distribution. Now the fourth distribution style is the auto. Okay, so let's first talk about the basic distribution style, and then we'll talk about the auto distribution style. So we have three distribution styles. So we define the distribution when we create a table. Okay, so if you define distribution for one particular table, the data for that table will going to get distributed across your compute node in that manner, the way you define the table distribution. Okay, so the first distribution is the even distribution. So by even distribution is the by default distribution. Okay, so in even distribution, the leader node distribute rows across the slices in round robin fashion, regardless of the values in any particular form. Even distribution is appropriate when table does not participate in join, or when there is no clear choice between the key distribution and all distribution. Okay, so what's happening in even distribution? When you load a data for a table where distribution is even, what will happen? Your leader node will going to distribute data across the slices in a round robin fashion. Means one slice first, then if there are so now say consider I have 5 node, 10 slices, and total 1000 records, and for this particular table I have even distribution. What will happen when you say load? What your leader node will do? Leader node is the one who take the decision. What? So now you give command for the even distribution, so it evenly distribute that 1000 record. Okay, so on high level you can just consider it as 1000 record, 5 node, 10 slices. So now do the round robin thing. 100 record to the first slide, 100 record to the second slide, 100 record to the third slide, fourth slide, fifth slide, till the 10th slice, node slice. Okay, so 200 record will be on each node, because my one node has two slices. So on my one node I'll be having 200 records. Okay, this is on high level. So this is what, so a round robin fashion. So it is in a circle. So the first node all the slices, second node all the slices, third node all the slices, fourth node all the slices. This is how it distribute in a even distribution. So this is default distribution, and the criteria for the even distribution, you can define even distribution for a table which doesn't participate in a join, and if there's no clear choice between the all distribution and even distribution, so that is the even distribution. Now the key distribution, which is very very important distribution. So this distribution is usually, means the clusters in the production usually based on this distribution. So in key distribution, The rows are distributed according to the value in one column. The leader node places the matching values on the same node slices. Same node slice, okay? Same node slice, okay? If you distribute a pair of a table on a joining key, the leader node allocates rows on slices according to the value in the joining column. So the matching value from the joining column are physically stored together. Okay, now the what is happening in the key distribution? We are distributing data rows according to the value in one column. Okay, now let me explain you this with example. You have a table where we are storing the country wise data. So say the country wise sales and all. Okay, now so for that table what I will going to do, I will going to define the key distribution. For now key distribution I have to define on a one column. That's what it the definition says. Rows distribute rows according to the value in one column. Okay, so I have to first I have to select the one column, so and then that column I can consider it as a key distribution column. Okay, so now this is my table where I have like the revenue, the country wise revenue. So what I will going to do, I'll choose the country column as a my key distribution. Okay, now for this revenue table I selected country as a key distribution, country column as a country column for the key distribution. So now what will happen when you load data in this table? Okay, so when what leader node will do, leader node will going to do for now in the country column there will be now say there are 10 countries: India, America, Australia, Japan, Germany, Italy, and two more countries. So we have these 10 countries. So when you define a key distribution for this table and when you say the load, okay, what leader node will going to do, leader node will going to distribute data according to the column called country. Okay, now what it will actually do, it will pull the data for each country. Now I have 10 countries, say 1000 record, 100 record for each country. So for India there are 100 record, for Australia there are 100 record, for Japan there are 100 record, and for Germany there are 100 record till 10th country, Italy 100 record. Okay, now when it will load data on your disk, it will load data in that manner only. So all 100 record for India will be on one node slice, all 100 record for Japan will be on one node slice, all 100 record for Australia will be on one node slice. So this is how it will load your data. So that's your key distribution. Okay, now let's talk about all distribution. Okay, so this is the easy distribution. What I'm going to do, I'm going to distribute entire your table on all the compute nodes. Okay, so copy of entire table is distributed to every node. I have 5 nodes. On all 5 nodes this entire table will be there, all the record will be there, all 1000 record will be there. So what happen in even distribution or key distribution, we distribute the portion of a portion of a table's row on each node, right? All distribution ensures that every row is collected for every join that the table participates in. Okay, so in all distribution what we are doing, we are like distributing entire table all node on all the nodes. So now we are considering the example of 5 node cluster, right? So the entire table means entire row in that table will be there on all the nodes. So you see what happening, redundant data, right? So what's bad with all distribution, it will, yes, it will increase your storage requirement. Now it is loading data across all the nodes. What will happen, your load time will be little bit higher. It will take like at least couple of seconds to load same number of records. So this is the things with this is the things with your all distribution. all but like what is the advantage of all distribution? You do join on anything for that particular table, data will be there on all the nodes, right? So your join will be super fast. So all distribution ensures that every row is collocated for every join that the table participates in. The all distribution multiplies the storage required by the number of nodes in the cluster. So it takes much longer to load, update, insert data in multiple tables. All distribution is appropriate only for the relatively slow moving table, the table that are not updated frequently or expensively. The small dimension table do not benefit significantly from all distribution because the cost of redistribution is low, right? So like for a small table, we put that table which do not get updated very frequently. For that kind of table we can use the all distribution. So like 2.2 million record is the threshold for the all distribution. So that's what like Amazon says. Now, so these are the basic three distribution styles. Your all distribution where we populate all the records to all the nodes. Event distribution we go round in a round robin fashion, and then the key distribution where we distribute rows according to the value in one column. Now the fourth distribution style is the auto. With the auto distribution, Amazon Redshift assign an optimal distribution style based on the size of your table. For example, Amazon Redshift assign all distribution to a small table and then changes to the even distribution when the table grows larger. Okay, when a table is changed from all to even distribution, the storage utilization might change slightly. That's obvious, right? Because we are going from all to even. The change in distribution occur in the background in few seconds. The Amazon Redshift never changes the distribution style from even to all, because that is wrong. Like I'm saying, my table is evenly distributed, and like I can Amazon Redshift on itself cannot go with that decision to make it all. Yes, but for so Redshift never changes the distribution style from even to all. In auto, it does only all to even distribution. Okay, so that's your auto distribution style. So like if you don't specify a distribution style with a create table statement, the Redshift defines Redshift, like Amazon Redshift applies auto distribution by itself if you do not define any distribution for a table. So it will be like the auto distribution. So these are the four distribution styles we have available with AWS Redshift, and you can apply this distribution when you create a table. So while creating a table, we can define the distribution. So if you do not mention anything, it will be auto. So these are the distributions. Now let's see how does it looks with the pictures. Okay, so this is the data distribution style. The distribution style is a table property, and that's what I mentioned. Like when we create a table, that time like we can define the table distribution, which dictates how tables data is distributed throughout the cluster. Now in the key, the value is hashed, the same value goes on the same location. So now see, this is my key distribution. You see this, the key A, key B, key A, key B, key C, and key D. Now imagine for this table, what I have done, I have selected one column as a key distribution. Now there are four values in that column, A, B, C, D. Now see what will happen when data will distribute. So the all the data for value A will be on slice 1, all the data for value B will be on slice 2, all the data for value C will be on slice 3, and all the data for value 4 will be on slice, all the data for value D will be on the slice 4. So all the data means all the record for value A will be on one slice, so all the matching pair. Okay, so for all the data, all the records for India, all the records for Germany, all the records for Japan, all the records for Italy, like that. Okay, now all distribution, the full table goes to first slice of every node. So this is very important. Okay, what we are doing, like when I said all distribution table will be available on all the nodes. Okay, but in nodes again, like we have slices, so what will happen, it will go to the first slice. So this is my all distribution. Okay, and my table will be populated to the slice 1 of node 1, and then the same copy of table will be there on slice 3 of node 2. So this will happen in all distribution. Entire your table will be there on all the compute nodes, the first slice of the compute node. Now in even distribution, we go round robin fashion, right? So this is my even distribution. The first, the slice 1, then the record from this table will first goes to the slice 1. Okay, slice 1 is done, then go to the slice 2, then go to the slice 3, and then go to the slice 4, size flow, size 4, like that. So we go in a circle. That's what the round robin fashion. Okay, now like what we should keep in mind, like when we decide the distribution style. So the distribute data evenly for parallel processing and minimize the data movement during the query processing. Okay, what does that mean? When you run a query, your leader node has to send the part of that query to the node compute nodes to do the processing, right? So redistribution should be very less. Your query should go, means the referencing data should be available there on that node for that query processing. It should be available. If it is available, then your query, your leader node do not have to broadcast, redistribute the thing. It will directly go to that compute node. It will see the reference data. It does, the slices will does their part, and then data will goes back to the intermediate data. That data is done, one slice done its own work, that data will go back to the leader node, and then leader node will get the data from all the slices and then will publish to the client. So that will happen, right? So redistribution is the key, means data should not get redistributed, broadcasted to the all the slice, and then your processing is happening. That should not happen. So redistribution, the broadcasting of data should be very minimal. So you should distribute table, you should distribute your data in such a fashion that there should be minimum data movement during the query processing. So that's only the key, like when we select the data distribution. Okay, so there are certain rules. Okay, this rule will help you, like when you are about to select table distribution. So there are a couple of rules. So this rule will help only to select the distribution style. So it's like thumb rules. As I mentioned, if somebody asks me to select the alt say can this table will be candidate for all distribution. What I'll going to check, I'll going to check the size of a table, I'll going to check how many records are there, and I'm going to check like how frequently this table is updating. If the table is not updating frequently, okay, if the table size is less, if it has not so many records, a million or some a million or something, okay, that table is the right candidate for the all distribution. Okay, if key distribution, I do not have a column with uh, high cardinality, or I have a column in a table with a high cardinality, and I do the frequent join on that column. I use the where clause, where country is equal to India, then that country column. So if I do this kind of filtration, then that column will be the right column for the key distribution. And if table doesn't participate in joins, and I want data should be uniformly distributed for a particular table, then in that case I'll go along with the event distribution. If I'm not sure like how fast this table will grow, what should be the right distribution, key distribution is not the right distribution for this table, in that case I'll go along with the auto. I'm going to define anything, and I'll let the cluster decide what distribution will suit for this table. Okay, so now the rules. So these are the couple of rules, so like which can keep in mind while selecting the table distribution. Okay, so distribute fact table and one dimension table on their common column. Okay, now like when we do the dimensional modeling, we have this star schema, snowflake schema, where we do the normalization things, right? So like if we have a normalized model and data model, so this is the expected thing when we define the key distribution, when we define the table distribution. You you have a fact table, and that fact table has mapping with so many dimension table. So what you can do for one of your important fact table and one dimension table, you can define the key distribution on the common column. So distribute your fact table and one dimension table on their common column. So mapping, right? If it is employee ID is there in your dimension table, and it is there in your fact table, so like for the same column on the fact table, you can define that fact table. For that fact table, you can define that employee ID as a key distribution column, because it is common column in both the tables, in your fact table and in your distribution table, in your dimension table. Okay, choose the largest dimension based on the size of the filter data set. Okay, so if you are selecting a any one of the column from the dimension table, then like that should be on the basis of a filtered data set, and it should be the largest dimension based on the filtered data set, like how many records are there for that column for particular values. So according to that, like you can select the dimension. So choose the dimension table based on the size of the filtered data set. Okay, now choose the column with the high cardinality in the filtered data set. Now you selected the now you found out the dimension table. Now get to any one of the column from the dimension table. So the right column will be the column with the high cardinality. Now don't apply the column compression encoding. Let the copy command select the column compression encoding. So when the first time you load the data into an empty table, the copy command analyze the columns and apply the column compression encoding. So let the copy command choose the column compression encoding. Yes, Redshift doesn't enforce any constraint, any primary key and all, but still you can define the primary key and the foreign key constraint, because this will help your query planner. in a great way. So yes, please define the primary key and the foreign key constraint, and then use the smallest possible column size. So the varchar, you have to store the timestamp. So varchar, say for example, you have timestamp value, and what you are doing in your stage table, you are storing it as a varchar, and in your base table you're going to cast it as a timestamp. Okay, so in base table varchar cannot be 250, because you know timestamp can be like in between 60 to 80 characters. So it should be minimum, because you know like Redshift stores everything in a 1 MB block. So if it doesn't fits in 1 MB block, it will create another block. So that block that block will be like partially empty. So it unnecessarily adds the burden. Okay, so it unnecessarily adds the, so if you define 250, it will create the block for 250. So it unnecessarily adds the overhead on your cluster, everything like the query scanning, it scan all the blocks. So it should be minimum. Your the smallest possible column size, keep the smallest possible column size. So you should know, like I know I have to store this timestamp as a varchar. So timestamp max to max can be like 150, not more than that. Even if it is with time zone, it can be like, it can accommodate in 70 to 80 varchar 70 or 80. But on the safer side, you can go along with the varchar 100. It cannot be like 250 or more than that. Okay, if a table is highly denormalized and no join is required, choose the even style. So this is one of the thumb rule. If you have a table that is a fact table and that is highly denormalized, okay, highly denormalized, the table is not normalized, no join is required for that table. Okay, so in that case, what will happen, will mostly going to retrieve all the column, right? So choose even distribution style for this call. Okay, now choose all distribution for small table that do not often changes. For example, table containing telephone SID codes against the country name, that code will not going to change, and the table will be like the small table. So in that case, you can select the all distribution. It is beneficial to select key distribution if a table used in a join. I told you like the employee ID from fact table and the employee ID from dimension table. Also consider the other joining table and their distribution style. So like you need to look at the distribution of your dimension table also, like when you are selecting the employee ID as a key column, the column for the key distribution. So these are the things like so these are the things with the table distribution. So you can either select the all distribution or the key distribution or the even distribution, and the latest one is the auto distribution. Even if you do not mention any distribution style, it will become the auto distribution, where it will change from all to even to all. It will not go back, it will not do the other way. So that's the all distribution, that's the auto distribution. So even to all, it will not going to do that, but yes, all to even it will be. If your table is small, Redshift analyze that this table is small table. Okay, so let's keep the all distribution for this table. Over the period, your table grows from 5 GB to 50 GB, or say from 50 GB to 500 GB. Okay, let's change the distribution. So it will do the this way, all to even, but it will not do the other way, that is even to all. Okay, so this is the, so okay, so this session was about the distribution, table distribution. So we should know like what all distribution and even distribution and the key distribution and the auto distribution. So if you know the background, so we will be having the practical session. I'll show you like how we create the tables, how we define the distribution. So that time like at least we can coordinate. So when we say uh, distribution is distribution as even, or distribution as all, or distribution as a key, and then we specify the column name while creating the table with the create statement, then that time like at least we'll come to know like what will happen in the back end when I say all distribution for particular table. So what will happen, all the data will be there on all the nodes, compute nodes, and on specifically the first slice of that compute node. So uh, I think we are good with table distribution style. So we know the type of table distribution style and what each table distribution style does when we define it for a column or for a table. Okay, so on that note, I'll conclude this session over here, and then for next session, we'll discuss all about the table sort keys. So again, the table sort keys will be very important, and that session will be a quick session. So where we're going to define the things, where we're going to discuss the things about the short keys, the type of short keys, and where and like in which scenario we can define which short keys, and like how it will help if we define the short keys on a column. Okay, so on that note, I'm just closing this session. See you at the table short key session. Thank you, thanks a lot.